right, team. Settle in. The shared responsibility model, security of versus in the cloud, looks intimidating on paper, but it boils down to a handful of decisions you can master today. By the end of this video, you'll know exactly who patches what, who configures what, and who gets blamed when a bucket leaks, for every major Amazon Web Services service tier. The shared responsibility model is the boundary line between Amazon Web Services and you, and most preventable cloud breaches happen because someone misread that line. In episode 3, we mapped where Amazon Web Services actually runs, regions, availability zones, and edge locations. We covered how multi-as deployments survive a single data center failure, and how edge locations sit close to users for caching. Today, we shift the question. It's not where the infrastructure lives anymore, it's who secures what once it's running. 5 terms to pin down before we go deep. Security of the cloud is everything Amazon Web Services owns: physical data centers, hardware, the hypervisor, the global network. Security in the cloud is everything you own on top of that: your data, your IAM setup, your configuration choices. Shared controls are areas where both sides contribute at different layers, like patch management. Systems Manager. Patch Manager is the Amazon Web Services service that automates scanning and applying OS patches to your EC2 instances, and an IAM execution role is the set of permissions a Lambda function assumes when it runs your code. Picture this: Code Gorilla's fintech client is sitting in an audit. The auditor leans forward and asks one scenario: who patches the database server? The team's first instinct is to say Amazon Web Services, because the database is in the cloud. But the honest answer is, it depends entirely on which Amazon Web Services service is hosting that database. If it's MySQL running on EC2, that's the customer. If it's the same MySQL on RDS, that's Amazon Web Services. Same database engine, different answer. The shared responsibility model is exactly the framework that resolves that ambiguity. Here it is in Amazon Web Services' exact wording from the official shared responsibility model page. While Amazon Web Services manages security of the cloud, you are responsible for security in the cloud. 2 prepositions doing all the work: the word of and the word in. This distinction is exactly what exam scenarios test. Here's the one-sentence version you'll come back to over and over. Amazon Web Services secures the cloud itself, the physical, the foundational, the things you literally cannot touch. You secure what you put inside it: your data, your access, your configuration. Everything else in this lesson is just figuring out where that line sits for a specific service. Think of it like renting an apartment. The landlord, that's Amazon Web Services, maintains the building. They pour the foundation, lock the lobby at night, run the cameras, fix the elevators, and keep the whole structure from collapsing. That's security of the cloud. You, the tenant, are still responsible for what happens inside your unit. You lock your front door, you decide who gets a copy of the key, you choose whether to leave your jewelry sitting on the windowsill. That's security in the cloud. And here's the part to hold on to: if you hand your apartment key to a stranger, the landlord is not liable. The building was secure, you opened the door. Let's draw the line concretely. On the Amazon Web Services side, you've got the physical data centers and facilities, the buildings, the badge readers, the biometric locks, the hardware and the global network fabric that connects every region, the hypervisor and the host operating system that runs your virtual machines, and the foundational services that keep Amazon Web Services itself running. On your side, you own your data and how you classify it. You own your IAM users, roles, and permissions. You own the guest OS and app config, where the service exposes that to you. And you own your encryption choices, your network rules, and your application code. The pattern: if you can touch it through the console or the CLI, it's yours. The official Amazon Web Services shared responsibility page makes one point that does the most work for understanding the rest of this video. Customer responsibility is determined by the Amazon Web Services cloud services you select. The boundary is not fixed, it slides based on which service you picked. Pick EC2, and you inherit a lot of work. Pick Lambda, and you inherit very little. Same model, different shape, and that's the framework for the next 3 walkthroughs. Before we walk through the 3 services, here's the analogy that makes the boundary stick. EC2 is buying groceries. Amazon Web Services hands you raw ingredients, the virtual machine, but you cook, you season, you clean up. RDS is a meal kit. Amazon Web Services preps the ingredients and patches them for freshness, and you just heat, plate, and serve. Lambda is a restaurant. Amazon Web Services owns the kitchen, the chef, and the dishwasher. You just describe what you want, your code, and pay per byte. Notice the pattern. As you move left to right, more is done for you, and your surface area shrinks. That's the model. Now let's make it concrete service by service. EC2 first, because it gives you the largest customer-side surface. On Amazon Web Services side, the physical host hardware, the hypervisor that runs your VM, the network fabric beneath your VPC, and the facility itself, power, cooling, physical security. On your side, the guest OS, every Linux or Windows patch, every kernel update, every common vulnerabilities and exposures advisory, CVE, that drops at midnight. You configure security groups, inbound and outbound. You install the middleware, the runtimes, the libraries, and you own your application code and every dependency it pulls in. If a critical Ubuntu vulnerability is disclosed tonight, Amazon Web Services will not log into your instance and run apt update for you. That's the deal you signed when you picked EC2. Here's Amazon Web Services' exact wording for EC2, straight from the shared responsibility page. The customer assumes responsibility and management of the guest operating system, including updates and security patches, other associated application software, as well as the configuration of the Amazon Web Services provided security group firewall. Notice the specific phrase, Amazon Web Services provided security group firewall. Amazon Web Services gives you the firewall. You write the rules. That distinction shows up over and over. Here's where teams trip themselves up. Amazon Web Services provides Systems Manager Patch Manager, a fully managed service that can scan and patch your fleet on a schedule, but providing the tool isn't the same as doing the work. Installing the SSM agent alone does nothing. Amazon Web Services documentation is explicit that you must configure patch baselines, assign patch groups via tags, and schedule maintenance windows or trigger run command tasks before any patches are applied. Amazon Web Services gives you the capability, the responsibility never moved. Now move that same database workload to RDS, and watch the boundary slide. Amazon Web Services now handles the underlying OS patches, no more kernel updates on your plate. They patch the database engine itself, MySQL, PostgreSQL, whichever you picked. They manage the hardware, run automated backups, and handle multi-AZ failover replication. But you still handle the things only you can know. You manage database users, schemas, and grants. You choose the VPC placement and security group rules. You decide whether to enable encryption at rest using KMS, and the data inside the database is, always and forever, yours. The boundary moved up, but it didn't disappear. This is the part worth slowing down on. The reason teams pick RDS over self-managed MySQL on EC2 isn't just convenience. It's a literal transfer of security responsibility. OS patching moves from you to Amazon Web Services. Engine patching moves from you to Amazon Web Services. Backups move from you to Amazon Web Services. That's Nexa Retail's Oracle workload from episode 5. They re-platformed to RDS, and the entire patching surface shifted. Same workload, smaller customer footprint, lower breach risk. All the way to the most abstracted end now, Lambda and S3. Amazon Web Services handles the servers, the OS, the runtime patches. They handle auto-scaling, concurrency, and for S3, 11 nines of storage durability. They handle the underlying network and isolation. Your surface shrinks dramatically, but it never goes to zero. You still own your function code and every third-party package or library you bundled with it. You own the IAM execution role that decides what the function is allowed to touch. You own bucket policies and block public access settings. You own the encryption settings and the data itself. The Capital One breach we're about to cover hit S3, and Amazon Web Services infrastructure was never the failure. Quick halfway check. So far, Amazon Web Services owns hardware and hypervisor, and you own data, IAM, and configuration. As you go from EC2 to RDS to Lambda, Amazon Web Services' slice grows and yours shrinks. Next, we look at the things that never shift, no matter how managed the service gets. Here's the spectrum on one slide. On the left, EC2, Infrastructure as a Service. In the middle, RDS, Platform as a Service. On the right, Lambda and S3, Serverless. As you move from left to right, Amazon Web Services responsibility expands, and your responsibility shrinks. But look at the bar at the bottom. 3 things never shift, no matter the tier. Your data, your IAM setup, your encryption choices, those stay with you on every service, forever. Burn this into memory. Data, IAM, and encryption choices belong to you on every Amazon Web Services service, at every tier, forever. It doesn't matter how managed the service is. Amazon Web Services provides KMS for encryption keys and Amazon Web Services Certificate Manager for certificates, but you have to turn them on. Amazon Web Services provides IAM as a global service, but you write the policies. Amazon Web Services stores your data with extreme durability, but you decide what to put there. Those 3 never move. Picture a bank vault to make it stick. The bank builds the vault, guards the building, and runs the cameras around the clock. That's Amazon Web Services. You pick the combination, and you decide who gets to know it. That's IAM. You choose what to put inside the box. That's your data. And if you write the combination on a sticky note and post it to GitHub, which is literally what leaked Amazon Web Services access keys are, that is not a bank problem. Botnets scan public Git repos for credentials and find them within minutes. The vault was secure. You published the combination. Same logic applies to the headline you've seen 100 times. Company X leaked millions of records from a public S3 bucket. That is always a customer failure. Amazon Web Services provides block public access, bucket policies, access control lists, and audit logging. Misconfiguring all of those at once is on the customer. A common misconception frames this as an Amazon Web Services failure. It is not. Bucket configuration is always customer-owned, at every tier. Amazon Web Services knows this is a problem, and they tried to help. In April 2023, they changed the default. All newly created S3 buckets now have block public access enabled out of the box. But read the second half of this quote from Amazon Web Services' own announcement. Although these new defaults create a strong security posture, you are still responsible for monitoring your users who may reconfigure these settings. The boundary didn't move. Amazon Web Services just made the safe default louder. Responsibility is still yours. Here's what happens when the model is misunderstood. Capital One, 2019, roughly 106 million customer records exposed, about 100 million in the US and another 6 million in Canada. The attack chain is worth understanding precisely. A misconfigured web application firewall on an EC2 instance allowed a server-side request forgery attack. That SSRF was used to reach the EC2 instance metadata service, the old version 1 endpoint, which handed back the temporary credentials for the IAM role attached to the instance. Those credentials were then used to read S3 buckets full of personally identifiable information. Every single failed control was customer-side. the WAF rules, the IAM permissions, the metadata service version, and the bucket logging. The Office of the Controller of the Currency fined Capital One $80 million as a result. Read this carefully. Amazon Web Services infrastructure was never compromised. The hardware was fine. The hypervisor was fine. The S3 storage layer was fine. That is the cost of misreading one slide. Now for the part that genuinely is shared. Amazon Web Services calls these shared controls. Patch management is the clearest example. Amazon Web Services patches the infrastructure and the hypervisor. You patch the guest OS on EC2 and keep your application dependencies updated. Same control name. Different layers. Configuration management and training work the same way. You configure your services and train your team. Amazon Web Services configures its own devices and trains Amazon Web Services staff. Both parties contribute. The boundary depends on the specific control and the specific service. Shared does not mean a 50-50 split. It means both parties contribute, but at different layers of the stack. For EC2 patch management, Amazon Web Services handles the hypervisor and you handle the guest operating system, both contributing, but at very different layers. For RDS, Amazon Web Services handles even the operating system patch, and your contribution is just keeping the data clean. Same shared control, different boundary. The service you pick determines where that line sits. Here's the single decision rule worth memorizing. When a scenario asks who patches the operating system, you only need to identify the service. If it's EC2, the customer patches the guest OS. If it's anything more managed, RDS, Lambda, Fargate, S3, Aurora, and so on, Amazon Web Services patches it. That one rule answers a huge fraction of shared responsibility scenarios you'll see. Identify the service, apply the rule, choose the answer. A few mental models worth correcting, because each one shows up as a real operational failure before it ever shows up on an exam. First, Amazon Web Services managed does not mean Amazon Web Services is responsible for everything. Teams assume a managed service means hands-off security, then ship an app with wide-open IAM, and wonder how data walked out. Your data, your IAM, and your config stay yours even on the most managed service. Second, on Lambda, Amazon Web Services patches the managed runtime automatically when ACVE is disclosed, but your third-party packages and libraries are still your problem. A vulnerable dependency in your deployment package will sit there exploitable until you rebuild and redeploy. Third, installing the SSM agent doesn't actually patch anything. Teams roll out the agent across a fleet, check the box on their compliance review, and discover months later that nothing has been patched because no one configured baselines or maintenance windows. And fourth, encryption defaults have shifted, and the nuance matters. S3 has automatically encrypted every new object since January 2023, and Lambda encrypts at rest by default, both using Amazon Web Services controlled keys at no extra cost. But for standard RDS instances, encryption at rest still has to be turned on when you create the database, and you cannot retrofit it later without a snapshot and restore. If you want customer-managed KMS keys anywhere, that's always an explicit choice you make. All four of these distinctions also show up in exam scenarios. Here's the keyword cheat sheet. If a scenario mentions data, classification, or encryption choices, that's the customer. IAM users, roles, or access keys, customer. Security group rules or bucket policies, customer. Guest OS patching on EC2, customer. On the other side, physical security, facilities, or hardware, Amazon Web Services. Hypervisor or host operating system, Amazon Web Services. Database engine or runtime patching on a managed service, Amazon Web Services. Global network infrastructure, Amazon Web Services. If you can match the keyword, you can usually find the answer. 5 things to hold on to. 1. Amazon Web Services equals security of the cloud. U equals security I in the cloud. 2. The boundary moves with the service. EC2 is customer heavy. Lambda is Amazon Web Services heavy. 3. The customer patches the OS on EC2, and Amazon Web Services patches it on RDS, Lambda, Fargate, and S3. 4. Data, IAM, and enabling encryption are always yours, on every service. 5. Public buckets and leaked keys are always customer failures, never Amazon Web Services failures. Now let's test what stuck with a 5-question check. Question 1. A company runs a MySQL database on an Amazon EC2 instance. A critical CVE is published for the Linux kernel. Who is responsible for applying the patch to the EC2 instance's operating system? Option A. The customer, because the guest operating system on EC2 is a customer responsibility. Option B. Amazon Web Services, because Amazon Web Services owns the underlying infrastructure. Option C. Amazon Web Services, because Systems Manager Patch Manager is an Amazon Web Services service. Or Option D. Shared equally between Amazon Web Services and the customer. Lock in your answer before I give it away. The right call here is A. On EC2, the guest operating system is a customer responsibility, including every kernel patch and security update. Amazon Web Services handles the hypervisor and the host below your VM, but everything inside the VM is yours. Option C is the classic trap. Amazon Web Services provides Patch Manager as a capability, but providing a tool and being responsible are not the same thing. Question 2. A startup migrates its self-managed PostgreSQL database from EC2 to Amazon RDS for PostgreSQL. Which of the following responsibilities shifts from the customer to Amazon Web Services as a result of this migration? Option A. Managing database users, grants, and schemas. Option B. Choosing whether to enable encryption at rest using KMS. Option C. Patching the underlying operating system and the PostgreSQL database engine. Or Option D. Classifying the data stored inside the database. Think about which constraint matters most here. It has to be C. The single biggest security responsibility that shifts when you move to RDS is patching, both the underlying OS and the PostgreSQL engine itself. That's literally what choosing a managed service buys you. The other 3 options, users, encryption choices, and data classification, never move. They stay with the customer at every tier. Question 3. A developer accidentally configures an S3 bucket to allow public read access, and customer records are exposed. Which party is responsible under the Amazon Web Services shared responsibility model? Option A. Amazon Web Services, because S3 is a fully managed service. Option B. Amazon Web Services, because the bucket is stored on Amazon Web Services infrastructure. Option C. Shared, because both parties contribute to S3 security. Or Option D. The customer, because bucket policies and block public access settings are customer responsibilities. Pause here if you want more time. If you said D, well done. A public S3 bucket is always a customer failure, never an Amazon Web Services failure. Amazon Web Services provides block public access and bucket policies as capabilities, and as of April 2023 they even enable block public access by default on new buckets. But configuring access is the customer's job. This scenario is often framed in a way that implies Amazon Web Services is at fault. It is not. Bucket configuration is always customer-owned. Question 4. Which responsibility always stays with the customer, regardless of which Amazon Web Services service tier they use? Option A. Classifying and protecting customer data. Option B. Patching the underlying physical host hardware. Option C. Maintaining the hypervisor that runs virtual machines. Or Option D. Securing the data center facility and its power systems. Lock in your answer before I give it away. The right call here is A. Classifying and protecting your data is one of the 3 things that never move. It belongs to you on every Amazon Web Services service, forever. The other 3 options are always Amazon Web Services job. You literally cannot touch the physical hardware, the hypervisor, or the facility. Those sit firmly on the Amazon Web Services side of the line at every tier. Question 5. Let's test a concept from an earlier episode. A workload runs in a single availability zone, and the entire data center experiences a power failure. Which architecture pattern would have prevented downtime while staying within a single Amazon Web Services region? Option A. Edge locations with CloudFront caching. Option B. A multi-AZ deployment across at least 2 availability zones. Option C. A multi-region deployment with Route 53 failover. Or Option D. Amazon Web Services outposts installed in the customer's own data center. Got your pick? Let's see. This one is B. A multi-AZ deployment across at least 2 availability zones is the smallest sufficient construct for surviving a single data center failure inside one region. Edge locations don't run general compute, so option A is out. Multi-region in option C works, but it goes beyond the single region constraint in the question. And outposts in option D solves data residency, not AZ resilience. When the qualifier says single region, multi-AZ is the answer. And that closes out the shared responsibility model. Security of versus I in the cloud. The decision rules from today come back again later in the Amazon Web Services, the Amazon Web Services Certified Cloud Practitioner exam mastery, so keep them handy. See you soon.